Every time you click Buy Now, a complex global choreography begins. Logistics is the highly coordinated flow of planning, moving, and storing goods, connecting the point of origin directly to your front porch. For decades, this network was optimized to hit exactly two targets: squeezing down the financial cost to the absolute penny and maximizing the speed of delivery. But that extreme velocity leaves a heavy footprint. To keep things moving that fast, transportation alone now pumps out 19% of the European Union's total greenhouse gas emissions. The damage goes beyond the atmosphere. Heavy freight traffic creates intense noise pollution that disrupts sleep and drives up cardiovascular issues in urban areas, while commercial trucks account for a disproportionate number of fatal road accidents. When we ignore these physical damages, we aren't saving money, we're shifting the bill. The healthcare costs from pollution and the lost productivity from traffic congestion eventually inflate the price of every item we buy, eroding the very market competitiveness the system was built to protect. Before we can fix a system of this scale, we have to measure exactly how much damage it's doing. This is where a carbon footprint audit comes in, a strict accounting of all greenhouse gases tied to an entity's operations. We categorize this debt into scopes. Scope 1 covers direct emissions from sources a company actually owns and controls, like the diesel trucks in its fleet or the furnaces in its factory. Scope 2 accounts for indirect emissions, the pollution created by the external power plants generating the electricity the company buys to keep its lights on. Then there is Scope 3, which is notoriously difficult to track. These are all the indirect emissions cascading through the company's entire extended supply chain, down to the manufacturing of the raw materials and the cargo ships moving them across the ocean. Accurately mapping all three scopes and drawing those boundary lines is the strict prerequisite. You can't engineer the waste out of a global supply chain until you know exactly where it lives. This chart breaks down how logistics CO2 emissions are generated. On the left are endogenous factors, choices a company controls, like warehouse placement and product packaging. On the right are exogenous factors, outside realities like global fuel costs and national tax policies. To pull those emissions down, logistics managers apply lean strategies. One significant shift is moving toward local sourcing to cut the distance raw materials travel. Another is increasing vehicle load factors, packing trucks to full capacity so companies stop burning fuel to ship empty air. We're also seeing broad shifts in fleet management. Planners are routing more freight off highways and onto heavy rail lines and massive sea vessels, which operate efficiently and emit far less carbon per ton, while gradually transitioning local delivery routes to electric vehicles. For the emissions that technology can't eliminate yet, regulators step in. Mechanisms like the European Union's emissions trading system use a cap-and-trade model, forcing companies to purchase carbon credits to offset their remaining footprint. Optimizing how a box gets from point A to point B now requires balancing aggressive internal efficiency targets against strict environmental regulations. When a package finally stops moving, it enters a warehouse. These facilities account for roughly 30% of total logistics costs across Europe and the US, making them a pivotal lever for both economic savings and environmental reform. A major area of waste is temperature control. Implementing green building design reveals layout matters immensely. A U-shaped or fishbone floor plan segregates loading zones and retains internal temperatures far better than a traditional rectangular box, which bleeds heat every time dock doors open. Lighting is another substantial energy drain in warehousing. By calculating precise light intensity levels for specific zones and integrating strategic window placements to capture natural daylight, facility managers can drastically cut their electricity waste. On the warehouse floor, the equipment moving the pallets is evolving. Traditional diesel engines are being swapped out for low-emission hybrids, fully electric models, and automated retrieval systems. This modernization directly connects to social sustainability. Advanced IT routing systems calculate the most efficient path for a worker picking orders. This prevents miles of unnecessary walking per shift, directly reducing physical fatigue and workplace injuries. Sustainable building design merges environmental targets with human safety. These facilities reduce energy demand while providing the ergonomic conditions necessary for a healthy, high-morale workforce. The final piece of the physical distribution puzzle is the material wrapped around the product itself. Packaging has a dual job. It has to absorb shocks to protect the goods during transit, while also acting as a visually appealing marketing tool for the consumer. But this creates a serious environmental paradox. The thick, non-biodegradable plastics and metals used to protect an item for just a few days of shipping often generate a larger, longer-lasting ecological footprint than the actual product they enclose. To fix this, the industry relies on a structured, sustainable packaging framework. Step 1 is reduce, trimming the size and weight of materials to increase shipping density. Step 2 is reuse, which involves implementing business-to-business take-back systems, so crates and pallets are returned rather than discarded. Step 3 is recycle, collecting packaging waste to recover base materials or generate energy. And finally, reform, the push to phase out plastics entirely and transition to compostable, biodegradable alternatives. Packaging can no longer be treated as a disposable afterthought. It has to be treated as a highly engineered, sustainable component integrated into the total life cycle of the product. When you pull back and look at the entire logistics journey, it becomes clear that applying rigorous carbon footprint and social impact assessments to every single node yields measurable systemic benefits. This is the foundation of circular logistics. It is the active evolution of the supply chain from a straight, linear path that ends in a local landfill into a continuous, closed-loop system of material recovery and reuse. We now have the tools to make this a reality at a global scale. AI-driven route optimization and autonomous freight vehicles serve as the final catalysts, scaling these sustainable frameworks across the entire global grid. But engineering the perfect route isn't enough. Reaching this future requires intense collaboration, where governments set smart policies, competing businesses share data, and consumers rethink instant delivery. The speed and scale of modern distribution is an incredible human achievement, but true economic progress in the 21st century is only possible when environmental stewardship and human safety are packed into every single delivery.